Here are the Antutu benchmark results. Next, we'll also take a look at their Geekbench 6 scores. Hello everyone. Now let's compare their screen and screen flicker performance. The Realme Neo 8 is equipped with an ambient color adaptive function. This allows it to intelligently adjust the screen's color temperature in response to varying ambient light conditions. It ensures the screen's colors are consistent with the surrounding environment, which significantly helps to alleviate eye fatigue. In contrast, the Redmi Turbo 5 Max does not possess this feature, primarily because it was designed to save on manufacturing costs. Additionally, the Redmi Turbo 5 Max's always-on display can only last for 10 seconds and doesn't support all-day display. This is because its display solution eliminated the RAM originally used for image caching, resulting in support only for video transmission. Therefore, when the screen is off, the main controller must continuously send image data, which leads to increased overall power consumption. So, the Redmi Turbo 5 Max doesn't allow for an always-on display. As you can see, the Redmi Turbo 5 Max's always-on display only stays on for 10 seconds. Both of these phones have linearly polarized screens. The Redmi Turbo 5 Max utilizes a dimming strategy that involves DC-like dimming for mid to high brightness levels and a 3840Hz PWM dimming for lower brightness settings. The Realme Neo 8, on the other hand, employs a dimming strategy that uses full brightness DC-like dimming across the entire range. Next, we'll take a closer look at their screen flickering performance. First, we'll adjust them to a uniform brightness level of 168 nits. At this specific point, they all utilize a DC-like dimming method, which means any screen flickering is solely attributed to TFT reset. When both devices are operating at the same 60Hz refresh rate, the Redmi Turbo 5 Max utilizes 120Hz DC-like dimming technology, whereas the Realme Neo 8 employs 60Hz DC-like dimming. As you can observe, the Redmi Turbo 5 Max displays black bars, one noticeably deeper and the other slightly less so. This phenomenon occurs because its 120Hz dimming is implemented using a 60Hz TFT reset mechanism. Consequently, due to the differing timing sequences of the true and false resets, their perceived depths are not identical. Therefore, at this particular moment, its ripple depth must be measured with reference to the 60Hz TFT reset, specifically the deeper of the two bars. Here you can clearly see that it is much darker than the black bar on the right, which belongs to the Realme Neo 8. This means it offers a much greater depth of blackness or a deeper contrast. When they are all operating at a 120Hz refresh rate, they are all performing a 120Hz TFT reset, which essentially means 120Hz DC-like dimming. When the Realme Neo 8 transitions from a 60Hz refresh rate to a 120Hz refresh rate, the visible black bars become noticeably lighter, indicating a reduction in the ripple depth. Next, we will compare their screen flicker performance when both devices are set to 45 nits. At this specific brightness level, the Redmi Turbo 5 Max utilizes a 3840Hz PWM dimming solution, which is based on either a 60 or 120Hz TFT reset. In contrast, the Realme Neo 8 is equipped with only 60 or 120Hz DC-like dimming, also operating with a 60 or 120Hz TFT reset. After the Redmi Turbo 5 Max implemented 3840Hz PWM dimming, its TFT reset ripple depth is actually lower than it was previously with DC-like dimming at higher brightness. At this point, the screen flicker ripple depth caused by its TFT reset is also superior to that of the Realme Neo 8. It's the same situation even when operating at 60Hz. However, regardless of whether it's running at a 60Hz refresh rate or at a much higher 120Hz refresh rate, the Redmi Turbo 5 Max still exhibits noticeable screen flickering due to its 3840Hz PWM dimming technology, whereas the Realme Neo 8, on the other hand, does not have any screen flickering caused by high-frequency PWM dimming, and this is precisely where a significant problem arises. So when we consider everything, which screen flicker method actually performs better? Currently, the industry hasn't reached a definitive conclusion on this particular matter, so it truly comes down to each person's individual experience. If you happen to be quite sensitive to PWM dimming, but you're not bothered by the screen flicker caused by pixel reset, then you should definitely choose a display that offers superior TFT reset flicker performance. Conversely, you would then opt for a screen that provides better PWM dimming flicker performance. Once the industry has a conclusion, I will tell everyone immediately. This is a comparison of Turbo 5 Max and Realme Neo 8's brightness and color consistency.
The video's end shows their tilted color-shifted condition.